For better understanding upcoming tutorial videos, we have to understand the basic physics of vehicle dynamics. We need to speak through grip, center of gravity, the relation between them, and the effect of changing them. Let's start with the first one, grip. To keep it simple, it is the relation between tires and the surface. The bigger the grip, the greater the force they can transfer to each other. The final value equally depends on both of them. There is a huge difference between running on rough, racetrack tarmac, loose gravel, or hard frozen ice shield. The pattern, the compound, and the size of the tires are just as important as well. At this point, I wouldn't go into details about the surfaces. You all know how harder it is to drive on snow than on tarmac, and wet concrete is more slippery than dry. Furthermore, the world of gravel is way too complicated to explain it now. Let's talk about tires. To every tire, depending on its properties, belongs an elliptic curve that shows the maximum force the touching surface of the tire can transfer into different directions. This elliptical pattern comes from the technology of manufacturing, so that tires could transfer more force longitudinally than laterally. In practice, this curve defines how hard we can accelerate without spinning the wheels, how much we can brake without blocking them, and how much force it can take mid-turn without slipping. At this point, let's examine what happens when we run out of this ellipse and we lose traction. The wheel that loses traction can basically be replaced with a brick. It may slow the car a little, but not so much. That's why we cannot control a car with blocking wheels. The vehicle is not really accelerating during a burnout, and we can't turn much with spinning front tires. So, our goal is to set up the car properly and make the ellipse as big as possible, then drive such way so that we stay inside the ellipse. How to make it happen, I will tell you in other videos. Let's proceed to our next participant, the center of gravity. To make it easier, imagine that we concentrate the whole mass of the car into a single point, then all the force connected to our vehicle is effective at this very point. From our point of view, it is relevant as the actual position of this point defines the load on each wheel. And this is important since bigger load causes greater traction on the tire. And just like that, we have the connection between grip and center of gravity. Now this is where the fun begins, because right after the car starts moving, there is not a single moment when this point stays put. Due to the inertia of the car and the typical suspension geometries, the center of gravity moves behind during acceleration, falls ahead when braking, and travels towards the outside of the curve while turning in. It is the same effect we can experience while sitting in the vehicle. Since the mass of the car is not changing, the extra load on some tires is equal to the lifting force on the others. This is the reason behind the spectacular phenomenon when lightweight FVD cars lift their inner rear wheels mid-turn. To summarize it, if the vehicle is moving, accelerating, braking, turning, the center of gravity will move. If it moves, the actual load of each wheel will change. If the load changes, then the traction of the tires will change, so the maximal transferable force as well. With this minimal knowledge, we can go on to the tricks and tips of rallying. If you like this video, consider to subscribe, as other rally basics videos are coming soon.